Welcome to Rubber Duck Engineering. Tonight, we're going to play with Wasm, WebAssembly, all this fancy new stuff that's coming to the browser and beyond. It's going to be fun. Hey, Dr. Barth.
Hey, Eric. I'm actually amazed we haven't done a WebAssembly episode yet, since we talk about it all the time.
Do we? I don't know. It all blurs together to me.
Well, it came up in the some of the Godot, I think, in Unity episodes, because those had the compile to web feature, which is, as I understand it, is built on top of WebAssembly.
I can believe that. I think we talked about that actually back maybe in the before Flutter or whatever, but I remember, WebAssembly when it was Knackle, and then when it was PNackle, and then it was Asm.js, which came from Mozilla, and then the great merger of the idea spaces and the standards community. I mean, I just remember playing that, and it's amazing. It's taken whatever that's been, 10 years?
A long time.
Long time. And I feel like we are really just on the cusp of WebAssembly really going big. I actually I'm not convinced that it's going to go big on the web.
Oh, so you think because I know you can run it inside a browser, but they also have standalone interpreters or compilers and such. You think those are where the exciting action is going to be?
So the most exciting thing that I have seen from WebAssembly yet is people using Wasm as an alternative to containers.
Yes, it's a capability system. William is exactly correct.
I've not personally dealt with it myself, but the idea is very compelling. The idea that you could, instead of shipping a Docker container around to run your thing, you could compile down your program and not have to bring along your, whatever language runtime and open SSL libraries or whatever. You just compile down your program to a single .wasm, and that runs, and ship it to the edge or whatever, and then that runs. And people who are much more into this than I'm sure can tell me that I'm wrong, but that idea sounds compelling.
Because it's lighter. The advantage is that it's lighter weight than a container. Is that the idea? Wasm is the next gen. Oh, is the next gen.
Yeah, it's lighter weight. As William alludes to, it has explicit, because of WASI, you explicitly opt into what you're handing into the system, which is nice. I mean, you do it with containers too, although you do that via ports, I guess. I don't know. Do we have other ways to run single binaries?
I mean, that's kind of what JavaScript has been, right? JavaScript is the way that you take portable code and you give it to somebody else, and they can run it either in Node.js or in a browser. I guess the thing I see that makes WebAssembly neat is that it opens it up to many other languages. Basically, any language that plugs into the LLVM toolchain can then output WebAssembly now.
But as you alluded to earlier, Wasm is actually in use today. I suspect that several of the Google Web properties use, although I don't know. I know that Flutter uses it we compile Skia, or we use CanvasKit to compile Skia. Word everything to Wasm, Snaplet.
So you can take things like Postgres, compile them to Wasm. We've used Skia compiled to Wasm on the show actually, for the render tree episodes, and then obviously Flutter uses it in production to get Flutter running in the browser. DuckDB is up and running. Yeah, why not? As soon as you can run all these complicated pieces of software as close to the user as possible, it's got to be better for latency, right? Why make the long round trip to Virginia, right?
I don't remember where it was, but tonight we're going to play with Wasm in the browser. I have set up basic hello Wasm. I followed the tutorial for
run Doom on the edge. I saw somebody was running Doom on their light switch or something.
Exactly. Doom on Notepad was on Hacker News last week. They were somehow using Notepad as a renderer, which didn't make a lot of sense
terrifying.
To me,
it's like ASCII art or something.
Something like that. Anyway, so tonight we're just going to play with. We're gonna poke it, as you were saying in the green room. We're going to poke at Wasm with a stick. I got the hello tutorial for using Rust. I looked briefly at doing it with Clang, just raw Clang and C, and I was suspicious I could get that working on my Windows box in time for the show.
Should we go to the code sheet and take a look at it?
Yeah. So we have it set up on So anyway, so I have just the super basic example. I actually hacked up the example slightly, or I used a slightly more complicated example. This isn't needed. This is trying to replace the allocated with a smaller one. This uses Wasm bindgen. I guess this is a macro.
That's a proc macro in Rust. I'm not sure what it's doing, but it's somehow generating some kind of Wasm goop for this.
And then it takes this cexposed function alert for a string, or sorry, this gives us the bindings for alert, window.alert. And this is our exposed greet, which calls alert.
So JavaScript is going to call greet, and then we're going to call alert. Is that?
If we look at the index.html I copied from so script type module, we import init and greet from hello wasm.js, which is something the Wasm binder will generate for us from Rust. And after init, we then call greet WebAssembly. And if we look at our hello Wasm.
Oh, I see. So alert in this case is literally like window.alert.
I believe
like
it is
the thing that pops up the alert dialog in a browser.
And this must do some sort of alert. I mean, we could read through this. This is like 100 lines of code.
You didn't write this code. This code was output by the.
Correct. This is auto-generated code.
Okay.
This is the JavaScript goop that wires up our Wasm blob to the JavaScript world. So we get a cached text decoder.
Mm-hmm.
I don't know what that's for. What are we decoding here?
I think. Oh, I looked at this a little bit. It looks like it's involved with like moving strings in and out of the JavaScript heap into the Wasm. I'm not going to say heap, but maybe it is the heap. I don't know. Wasm memory of some form.
Sure. Okay, and then we have our cached uint memory 0. Actually, this probably is our memory.
Mm-hmm.
Get our memory. Yep. Get string from Wasm. Use our decoder.
I see. So it rips out a bunch of memory, about like a slice of this type data, and then sends it to the text decoder to decode it, which can then give us back a JavaScript string. Okay.
Okay. So this must be to just it decodes null to like warm up the decoder or something.
PyScript is out there too. Python on the browser. Does that run using Wasm as its backend? It must, I guess. That's.
Okay, and then we have Wasm vector length 0, cache text encoder, and code string. This is presumably the same idea. This is if encode into is a function.
I see. This is probably like browser compatibility.
Yeah,
they must have added some like more efficient.
Yeah, this is a polyfill for encode into basically. I see. So if we have encoded into
that view,
whatever. Otherwise,
we'll do it ourselves.
We do it ourselves. Yeah. Okay. Pass string to Wasm. Malloc and realloc. Okay. If realloc is undefined, we use malloc. Okay. Otherwise, we.
So this malloc is calling into the Wasm environment, or this is like the malloc that we have. I get so confused in these things, like what's on what side of what boundary. Maybe we'll figure out where malloc comes from here.
I believe that. Yeah, I don't know. Okay. I have some ideas, but they may be totally wrong. So I'll just save them until we see. Okay, malloc. So we malloc a buffer for our string. Okay.
Yep.
And then we get our memory because you just have a blob of memory. Okay, so we walk our string. We just stop.
Non-ASCII character.
If we get a non-ASCII character, it's a little odd. And otherwise, we just set it in. I guess we're assuming.
Oh, maybe this is like Maybe there's like a
UTF-8.
performance optimization for ASCII strings where they'll do the ASCII part of the fast path, and as soon as you hit a non-ASCII character, then they're like, all right, we got to do Unicode now. Let's break out the Unicode guns.
Oh, I see here, because yeah. So we failed to get all the way to the end. So this is where we're going to try again, this time with Unicode. Makes sense. Right, so this is the fast path for ASCII, and as you said, otherwise we break out the Unicode guns.
Oh, I see. It reallocs with 3 times the arg. So this is because any Unicode string, the longest encoding sequence in UTF-8 is 3. And so the maximum length is 3 times the number of scalar values you have.
There are other trade-offs you could make here, right? This is the safe generated code, right? With
but it's very like memory inefficient, right? Because you're allocating, and oftentimes 3 times as much memory as you need.
The moment you hit Unicode, you are, yeah. Well, I mean, your other choice would be to walk the UTF-8 string once, figure out how big it's going to be, and then encode. You could write a much more complicated encoder here.
Well, this is why I think I'm surprised that the browser doesn't provide a built-in for this, because the browser is basically doing this constantly to deal with translate UTF-8 to JavaScript strings, and like it's got highly optimized routines for these sorts of things. Maybe that's what encode_into is doing. Encode_into is probably the optimized. I remember working on this code when I worked on Chrome, because it turns out to be very important to optimize.
Yeah, I could totally imagine. Oh, I see. So hold on. So this is encode string. Either we use this one. Yeah.
Or we polyfill it.
Oh, we call it code. But that's different.
Yeah, the string builder pattern, just to say what William was talking about, is it's basically allocating all the space up front that it thinks it's going to need. The way a string buffer would work is it would allocate a certain amount of memory, go until it hit that limit, and then allocate some more in this exponential pattern so that you wouldn't have too much overhead from copying things.
Lots of trade-offs. Okay, so now we export. This is where we're passing out the Rust function. So this is the actual implementation that JavaScript sees. We convert our string into Wasm with our Wasm bindgen malloc and our Wasm bindgen realloc.
Why is Wasm vector length always a constant? That's surprising to me. Oh, it's like stored in a global variable? What? That's a little wacky.
I assume this is our like end of our memory pointer.
No. If you look at this function, it returns a pointer and then shoves the length essentially into this global variable, which then is grabbed by this other. I really would not have done it this way. I mean, maybe this is like super important for performance, that like maybe there's no efficient way in JavaScript to return 2 integer values, that they have to return the second value through a global variable. But that seems kind of indirect.
Okay.
You've got a puzzled look on your face.
No, I mean, I see, but I'm just trying to think of other ways you, like, if nothing else, you could have a global object that was your thing that you pass.
Or pass in a reference to an object with 2 fields, and you stomp on both fields.
Exactly. Well, it just feels weird that one of your things is returned as a local. Whatever. Anyways.
This is the thing where, like, if I were working on this, and for whatever reason I determined this was the actual sensible way of doing this, I would write a giant freaking comment on this Wasm vector length global variable explaining, like, what is the contract for it, who stomps on it when, like, why we did this, like, what is the benchmark that shows that really this is the only way this is going to be fast.
Yeah. Okay, so, and here, this is the async function load. So sorry, this is the, I believe we call this, or maybe we call a init. I think we call a init.
I think we call a init, so we could trace it down from the
init
top.
probably calls load. So here's a init. We try and load.
It's like a default argument. Like if you didn't pass an argument input, it makes up one for you.
1 second.
I always find these things fascinating. So before Wasm was built into LLVM, there was this project called Inscriptin. And Inscriptin sort of bridged the gap between the ASM.js world and the WebAssembly world. And I remember really early on, actually the first Dart program I ever wrote used ASM.js. It was a free cell game, and I had found a free cell solver that was written in C that I managed to compile using Inscriptin, and then use that in my. I used the Dart for the front end. It was like a Dart on the web. And I remember looking at the actual like JavaScript that was generated by Inscriptin and just being like, what is this? Because there's this giant pile of all this kind of crazy code like this that all been like optimized to run real fast.
This was back in the ASM.js days, I assume.
Yeah. This is the ASM. This is really the prehistory of all this. Like what Wasm is significantly more like structured and sensible than ASM.js. ASM.js was like this giant glorious hack that made all this stuff work. But reading this file, I was just saying, reminded me of the ASM.js days, in the sense that it has these hacks that I presume are really important for performance.
Okay, so going back to init here, so we make a URL, which is I guess now a thing in browsers. Back when I joined browsers, this was not a concept that browsers understood.
They understood it internally. They just didn't.
They didn't expose the idea of you can actually make a URL, despite it being the fundamental of every URL parsing. There were all sorts of URL parsing libraries. Get imports, we can go look and see what that does in a minute.
Just to digress on that, so I at some point I wrote a conformance test suite for URL parsing in browsers, but it predated this URL object. As it turned out, the anchor element, the like A element that you use to make hyperlinks, if you set the like href property, the hyperlink property, it had other properties that were generated that would show you how the browser parsed the URL.
Yes.
So I wrote the whole conformance test suite based on that to like figure out like how do different browsers handle crazy.
I remember this.
Malformed URLs. And so I think at some point somebody sensible said, okay, why don't we just make like a actual URL object instead of having everybody use an anchor element to do their URL parsing. I remember
people like literally use the anchor element to do URL parsing.
Yeah, I mean, it was there, right? It worked. It just like, it was like way overkill to have an entire like HTML element doing what you wanted as a string parser.
All right, so we build up our URL. I don't know what import.meta does, but that must be part of the new magical import system or something.
I think this is a module, so I think that's part of the module system, JavaScript module.
Request is also something that has come in the last 8 years, I guess, since I left the browser world. For fetch, I remember fetch coming right at the end. Okay, init memory. I don't know what that does, but it does nothing. Okay, init memory, and then this is load. This is where we were getting, and then finalize init. All right, let's see finalize init before we read this. So finalize init takes our instance and grabs its exports and calls that the Wasm variable. Okay.
Okay. So we saw that before because we had saw wasm.greet, which makes sense. It took the things exported by the Wasm module.
And then init, our Wasm, our wgen Wasm module, that is our module.
But init is a function, right? So it shoved this random expando on the init function to remember that we had this. I'm curious, can we search this file for that identifier? Like, what is that used for? Nothing.
Maybe that's part of maybe something that wbindgen reads.
I don't know. Oh. Maybe we had a more complicated module be used for something.
Okay.
It seems weird to just shove the module on a random expando on this function, but
And this cached uint memory. This is our memory.
I believe that is the memory that's visible inside the Wasm environment, like byte for byte what's there.
I see. Wasm memory buffer. Okay. All right, great. Because I recall, I could be wrong, but I think Wasm, you just get a block of memory.
Mm-hmm. Yeah, you just get a linear address space. That is here's your memory.
So I think the last thing we have to look at is, we got kind of in the weeds here, but this is how I learn things.
What is get imports?
Get imports. Okay, we make a map or an object in JavaScript, I guess. Imports WBG.
Okay. I don't know what WBG is. Oh, this is alert.
Binding generator or whatever.
I see. When we exported alert, it got this crazy hex name here. I bet that's web bindgen, Wasm bindgen, WBG.
Something like that. Anyway, so this is the part that really needs to be generated of this function, right? Because it's having to pair this name with whatever it wrote down in the Wasm.
Mm-hmm.
And so it makes a real JavaScript function that calls alert.
Oh, it's fascinating to me. This takes 2 arguments, because when we wrote this in Rust, it took 1 argument, which was a slice. So I guess the slice must decompose into 2 arguments, one being the pointer and one being the length.
Well, we saw that earlier in the greet, right? So greet on the JavaScript side takes a string.
Mm-hmm. Oh, I see. And you're saying on the Rust side, greet also took a slice.
Greet, let's go look. But yeah, I'm pretty sure.
Mm-hmm.
That may also be part of the C stuff.
Oh, you think when you extern C, just normally normally can you extern C a thing that takes a slice? Because that's not like a C type, right?
I don't know. You'd have to. I don't know. I have a browser open. I don't easily have a browser open. I don't know. We'd have to look it up for Rust, but that's very possible.
So I think there are like 3 pieces here. Let me see if I just let me say back to you what I think we found here. So there's the there's LLVM toolchain, which is taking this Rust code that we wrote and converting it into this Wasm binary format, which we might want to explore a little bit.
Yep.
There's the browser, which has the Wasm runtime, and then there's this Wasm bindgen that's generating a bunch of goop to like plug the 2 together.
Correct. And to riff on that just a little more, to be clear, the LLVM toolchain, that's because Rust sits on top of the LLVM toolchain. And so you can tell Rust to, hey, use this LLVM backend instead, and it'll spit out Wasm.
I see. So just like to connect with last week's episode, so if we were using Zig, my guess is it would be easy to get the first of those things, to get to tell LLVM, like, okay, we ate Zig in the front end, back end, please emit Wasm. But maybe it exists or maybe it doesn't exist, but the bindgen piece of it we would be missing. And so it would be annoying to bridge calls back and forth.
Yeah, I don't know enough about bindgen, but I did briefly go to the GitHub repository and I had to, build and install it. But it seemed like it was a lot of code. I think there's a lot going on there.
It looks so simple. It looks so simple in the source code, right? Because you just put this little macro at it, and it's like, oh, make this thing appear in JavaScript, right? Yeah. But I'm not surprised that that's doing a significant amount of work.
I don't know. Oh, hey, look, we could jump to definition.
It's a proc macro. I find proc macros very difficult to understand by reading it, because they're operating at this meta level, right, where they're looking at all the tokens. They're like in the compiler, basically.
This one looks relatively simple. It just takes tokens. If config feature is equal to exit only, it prints them. Otherwise, it just gives you back the token. So it feels like this doesn't do anything.
I think it calls this expand function. Wasm bindgen macro support expand.
Oh. Yes. Token stream. Okay, we can see what the heck that does. Whoa.
Yeah, I think we're going to deeply get into.
We're kind of down in the weeds here, yeah.
Yeah, I'm interested in exploring the binary format. Could we look and see the actual Wasm file that we?
There is. We might have to install. I feel like we did this before. It's like a Wasm disassembler or whatever.
WebAssembly toolkit. Ooh, essentials pack.
I think I've installed this. So I think I may be able to show WebAssembly.
Oh, that's cool. So I think this file is actually on disk as a binary file. I think what you just did is your extension disassembled it for you.
Well, Wasm has 2 formats. They have the binary. There's a binary format and there's a text format, and they're the same. You and I looked at Wasm a year or two ago. That's why I have that extension installed, and I remember doing this. I suspect this is just a ton of Rust goop, because it's like I don't think we actually have 7,000 lines of assembly.
Hello world greeting, load and store.
Yeah, and that's why I was getting to. So this is a slightly more complicated example, slightly more complicated setup than is the default on like the Mozilla guide, but it's more akin to what the Wasm bindgen sort of points you towards. If I can find the cargo toml. So they do a few things, like I probably don't need this rlib here. We just generate a clib, which I guess somehow gets turned into, like somehow that clib instruction gets then with a backend turns into not actually a clib, but rather a Wasm lib.
It makes sense, like cdilib, because you have to, like for a dilib, you have to define your imports and your exports, which is also going to be important in this situation.
This is probably actually a bunch of the goop or some of the goop. I remember reading that if you avoid panicking, I think you save a bunch of size. This is probably turns panics into console logs.
Yeah, so on Fuchsia we set panic to be abort, and that saves a lot of binary size because, you know, I guess Rust has a lot of panics.
So this is the magic where we pull in Wasm bindgen, which it turns out I couldn't actually build myself on Windows because I didn't have the right OpenSSL dependency or something like that. But you go to the website and you can download and install a pre-built one. And okay, so this is just telling us of the console panic hook. Oh, I see. So we could just turn this off, and this would make our code size smaller.
Do you want to try that? I'm curious what effect that has.
When I was making changes before, it didn't seem to make code size. So like I was actually looking at that. So this should be the thing we're building. Mm-hmm. And this should be the command to build it. So we're 17K.
Okay.
If I turn off this feature, should
well there. You probably have to turn it off also at the top of the file where it was mentioned.
Somebody's sad at me. Oh, I see. Okay. Are we back? We're back or are we sad? I think we're back. Okay. So if I turn off that feature and then I rebuild, theoretically this is rebuilding. Mm-hmm. We are still the same exact size, even though we just built again.
Do you want to try using panic equals abort? So there's a similar package called panic abort. I'm curious if you try that one, what effect that will have on the binary size.
Well, I haven't made the binary change at all. Like, I think if I turn off these, mm-hmm. I added the LTO, which is another recommendation. I just think I'm doing something wrong. Same size, right?
17. Hey, Kevu, welcome to the show.
Oh, I actually just made it smaller. Hey,
how did you make it?
By turning off opt level S.
That doesn't seem right.
Well, this gets, what I believe is going on is that like we don't have anything to optimize, right? The 17K is all just the Rust boilerplate goop.
I see.
Right, and so the question is, could we turn off a bunch of that goop with the panic abort or something like that? But I don't know without staring at it, what is the goop?
I wonder if we could do things like no stid and stuff like that. Sorry, this is also sort of a tangent, but like I'm very interested in binary size because if the idea is you're going to throw these things over the network all the time and like have a ton of them, like the size becomes important.
I mean, 17K as overhead is not terrible, but it could be better. I guess also one other riff on that. This is also just how I learn, and I think somewhat how you learn too, is that you just follow the threads you're interested in until you like have enough roots in the system that you start to understand it.
Yeah, especially like when what is it? I read something somewhere where like medicine doesn't really advance with healthy people. Like you have to observe sick people in order to say, oh, this is now something wrong. Now we can figure
Uh-huh.
out how to change it. And so this is like a working thing. And so I want to, that's what, when we talk about like poke it with a stick, I want to like break it a little bit and then see
Yeah.
what went wrong.
Yeah. So I added back 16 bytes. So if you know how to turn that on that abort thing, we could try that. I also tried turning on this wealloc. That didn't seem to. Wealloc is a tiny allocator that's only 1K in code size compared to the default allocator is 10K. So I expect this could save us 10K, and maybe I didn't quite turn it on correctly. Like maybe I missed because I copied and pasted two cargo tomls together, and maybe I missed a line that like replaces disables the standard allocator. So I turn back on wealloc. No change. Okay. You with us?
Yeah, I was just looking at how to do turn panics into aborts.
Oh, okay. I suspect I didn't install wealloc correctly, which is why it probably didn't actually reduce our size. Other things we could look at. Like I don't think trying to read this is going to be successful.
Oh, look, there's a crazy alert WG with a bunch of hex numbers after it.
I don't actually know what this means. I see. This is import from this module, this function, into this type. I assume this is a symbol.
Yeah, and does that string appear elsewhere in the file? I'm just curious. I see. We call it.
Here's some function.
Function F25. I would be interested in defining like a new function inside JavaScript and then trying to call it from inside Rust.
See, greet is actually F25.
Oh, I see. Greet is like a little wraparound F25.
Huh. Wonder why they do
pushes things onto the stack.
I'm sorry. Define a new method in JavaScript. I think we could do that. So if we just go here, I think if we just do function foo.
So can we pass like a floating point number, for example, just as.
Sure. I think if we do that, and we go to this, I do pub fn foo n
like F64, I guess.
F64, sure.
And then can we try calling it from greet?
Greet. Greet's here, isn't it? Where is it? Oh, here it is. We want to. Ooh. Okay.
This is also my learning mode where I try to like see, okay, can I replicate the example code with a thing of my own?
Okay. All right, so now we want to. Now we have to serve this. This URL doesn't work, but here, I'm going to actually hide my screen for 1 second while I give myself a new browser.
I think it's fascinating that the type information is on the Rust side. It makes sense, right? Because JavaScript isn't really typed.
Yeah,
sure so like
doesn't care.
Yeah, I guess if you had an environment where if it wasn't a browser that was providing the runtime, but it was something else that also understood types, you probably need like an equivalent to bindgen that made sure the types lined up.
So this looked like it failed.
Okay.
So this one is fine. This is expected. 404. I don't know which this. Oh, this is expected. It's trying to get the like extra debug information.
Okay.
But this should pop up an alert. If we inspect, uncaught promise. Foo is not defined.
Okay, so foo, maybe because we defined foo inside this module script, it's not global enough. Maybe we need to define it in a global script somehow.
Wasm, Rust, define, expose JavaScript. Rust Wasm. From the module, mod.
That's the Rust side, right?
Well, that's the part that's wrong, isn't it?
I think the JavaScript side is wrong. Okay.
Let's see this here. Okay.
Can we try it just in the, we go back to the HTML file for a second?
Sure.
Like, I notice this is script type equals module. And I wonder if that's causing some kind of scoping to happen. I wonder if we just move this into a regular script that isn't a module, if that would make a difference.
Oh, interesting. All right, possible.
I'm just curious whether that changes things.
Okay, we want this. That fixed it.
Oh, and the console log did show up.
So this is some sort of unnamed module that we weren't importing from?
Yeah, I think this is like a fancy new JavaScript feature that lets you import other modules. And I think it's not doesn't pollute the global. Like I think after this, like I don't think greet and init are in the global namespace, but because this is an old style script, this foo just got shoved in the global namespace because that's
this window.foo or whatever.
Yeah, it's just how like JavaScript used to roll, right?
All right, so there we maybe with the script tag there's some way to name the module, in which case then we could have exposed, because that was what this was. Oops.
Oh, that was showing us how to get it from a named module?
Yeah, this was Wasm import module mod.
Oh, I see. Oh, that's cool. From the module mod. Okay. Do you want to see? I mean, that's probably an easy thing to look up, whether like a script tag type module. The whole JavaScript module thing came after I stopped paying close attention to web stuff.
Yeah, I mean, we left the browser world 8-9 years ago now, at least professionally. There's an example.
I don't see anything obvious about how to name the module. It's fine.
Script type module.
So things I'm always tempted to do with these things is to use them to draw pictures. My instinct is like, oh, I want to slap down a canvas and I want to plumb the draw circle command through so I can draw a green circle. I don't know that we particularly learn much from that. Like we've shown that we can transport a floating point number. I'm sure we can transport multiple floating point numbers. And so replacing foo with draw circle is just sort of it seems straightforward to me.
Yeah, I think there's a whole bunch of things that are interesting to do here. I don't have one that fits inside 20 minutes here. I think it's interesting to try using Wasm outside of the browser, see what that's like. I suspect they're not as like portable. Like I don't even know if WASI's been finished being standardized and stuff, but I don't know like how actually portable Wasm modules are. They may be like very specific to the compiler or very specific to the browser or not. I don't know. I think it's also interesting, what sort of things what would you put on both sides of the line?
Yeah, I think canvas is cool. I guess I'm interested in it's clear from reading the whatever that JavaScript binding goop we were looking at that passing strings is not the efficient way of moving data in and out. Like once you're encoding and decoding the string and like allocate, like calling malloc inside the thing, like that can't be the right way of moving significant amounts of data around. Like if you imagine like a Canvas API where one of the calls is like draw image, right? How would you move the image data between these two environments?
I don't know, because I don't know.
The thing I'm not clear about is so I saw that we called malloc when we passed this string in. Where did the string get freed? Like if we called greet a bajillion times, would we leak memory? You understand the question I'm asking?
I hear you.
Maybe we should look inside the like maybe it's the Wasm's modules job to free it, or maybe I should ask the question: where does this malloc come from?
Well, there's this Wasm bindgen malloc,
Okay,
which is an import that we got.
so can we look inside the Wasm module for what that looks like inside? But this is a thing implemented inside the.
This is provided to you by the. It's actually not very long.
Okay.
Block B0. Is there a free? There's no free.
Free may just have like one of those crazy names, like.
Well, I mean, I'm sure we can learn about it. Like, there's a bunch of questions that cross my mind. Like, what is the calling convention here into Rust? As an example, because I remember when I was doing.
I'm just going to ask you, when you say calling convention, what do you mean by
that? So like here, we pass string to Wasm. We get a pointer back out. That is a malloc pointer. Presumably, so is greet supposed to delete it? Or
maybe should we look inside greet? Like,
well, greet was very able to tell. This.
Well, I mean, look at the generated code for it to try to see if there's some like obvious thing that it does with the argument other than what we.
Well, so based on this calling convention, in Rust at least, you would not expect. You're not being passed ownership of this. You're getting like a pointer to a slice to a string. You don't delete the string.
Yeah, definitely the Rust source code is not deleting the string. But I'd be interested in like, is the Wasm generated code, like did they create like a bindgen wrapper around it that isn't expecting a malloc string that it's going to free?
So greet is.
Yeah, so look at this. So I think it calls F26, which I bet is the actual implementation of greet.
Correct.
And then afterwards calls F4, which I bet is free.
Well, what was that if?
Probably if it was non-zero. Like if there was a. Is this actually close to malloc? I'm just curious. F4 is has like a such a small number. Like it's tantalizing.
Malloc.
No.
Is F40, it appears. Wasm, Rust.
I assume it doesn't leak memory. It would be nutty if it leaked every string. Like that can't be right? That would. But like I wonder. So for example, it seems like the Wasm memory is stored in an array buffer.
Wasm assembly does not offer any instructions to deallocate memory. Increase the allocated size.
Yeah, this is a sadness about. So normally in an operating system, there's a operation called decommit, or in future we call it zero, where you basically tell the OS, okay, this range of memory that I've been working with and is dirty. I don't care anymore about it. Like treat it as clean and reclaim it for other purposes. And as far as I understand, Wasm doesn't have the decommit operation to say, I don't care about this part of the array buffer anymore. You can return it to the OS.
Wasm bindgen memory management.
You're like looking for a design doc for Wasm bindgen to see how they do this?
I'm just trying to get, like, somebody else must have asked this question.
Mm-hmm. I have a different question.
Sure.
So the memory inside the Wasm environment is this array buffer.
Mm-hmm.
Is there like an efficient way for me to return to JavaScript an array buffer view of some slice of that memory, like a zero copy view into the Wasm memory? Because that would be the most efficient way of taking memory from inside the environment and exposing it outside.
Well, isn't that what...
This is definitely doing that. Like if we look at the encoding into things, that's exactly what it's doing.
This Wasm memory buffer, right? This is, I presume, zero copy?
Uint array. Yeah, I believe this is giving you a view. I get confused between which ones of these are views and which one of these actually own their underlying storage. I believe this is giving a copy. Yeah, this is giving you a new zero initialized thing of a certain length.
Well, we're not using the...
We're passing in a buffer. So maybe this is giving you a view on the same buffer.
Well, let's see what the
Wasm binary that we're looking at right now is 17 kilobytes, which seems like a lot, but it's like we've written basically a trivial amount of code. And so I think that the code size that we're looking at is basically 17 kilobytes as, at least in our configuration for Rust, the sort of baseline overhead, and then the code you write is on top of that. I've definitely seen other setups in Wasm where the baseline is very, very trivial, like almost zero. But then you have to get into sort of either writing in C or using no SCD, or basically removing a lot of dependencies from your native code.
So I think this is what it's ended up calling. So I suspect it's this one, which is this. When called to the buffer and optionally byte offset and length, a new typed array view.
View is the key word in that sentence.
Is created that views the specified array buffer. Mm-hmm. So presumably, this WebAssembly memory prototype buffer is an array buffer. Buffer is either an array buffer or a shared array buffer.
Right. So I'm curious, like, what do we write in Rust as our type in order to get bindgen to shuffle these views around? Right, because like I want to make instead of foo, I want a bar function, and the argument I want to pass to bar is a view over some Wasm memory. Because like that's got to be the most efficient way of returning data out of the environment back to JavaScript. Wait, that second link looked super promising. What was that second link?
This is passing in, but
I see. But maybe we should try doing like a slice, U8 slice. Passing in is harder, right? Because passing in, you have to, if I just have an array buffer, there's no obvious way of slamming that into the linear memory for the Wasm environment other than copying it, right? But on the way out, you already have it in this linear array buffer. And so you should, in principle, be able to create a view of just that range of it.
So I don't know what this JSSys is. But this is part of the Rust Wasm GitHub.io and part of Rust Wasm. So presumably this is the Rust API onto array buffer.
Should we try?
My
Like, you
guess
want to try
would be we
adding?
could return one of these.
Well, let's try it. Let's try adding a dependency on this crate and making one of these things and returning it, and then seeing if we can look at the glue code to see what crazy nonsense it's doing to it.
Just seeing if there's like this feels like a common thing. Oh, so here we're at the Rust Wasm docs for Wasm bindgen.
Mm-hmm.
We have supported types. Supported.
So the previous page you were on showed how to. This looks like the efficient copy in path, where on the JavaScript side you make a typed array, and on the Wasm side you get a slice. Sorry, on the Rust side you get a slice.
Mm-hmm.
But I bet that involves a copy into the environment.
What's WebSys? This is WebSys, which is different from JSSys.
Oh.
JSSys crate. Bindings for all JS global objects and functions.
Uh-huh.
Okay. So I'm getting nightmares back from Dart.
Oh, so I bet this allows you to interact with array buffers. Like, it's probably like an export declaration that allows you to interact with array buffers, which is not quite what we're talking about here. We're talking about sort of like a lower level transport concept as opposed to like an object concept.
Rust type conversions.
From Rust to
Still
JS.
Going in. From JS. No.
Okay, Rust to JS is going out. Okay. So you have a stack and you return a Wasm. Okay. Into ABI function. Return the ABI. What is ABI?
Mm-hmm. I feel like this is where our learning style is breaking down, and I need to just like sit and read some of this.
Tell me more about the working style breakdown, because you're now in a mode like you poked it with a stick, you've gotten a feel for it. Now you want to digest the docs to learn more about it. Is that?
I don't need to read the whole docs, but I feel like my smell test here suggests that what we're trying to do, like my feel of this is that people have spent a lot of time on this Rust Wasm interop. And so somebody must have asked the question of how do I do zero copy?
Well, you could ask Google like zero copy, Wasm bindgen zero copy. Because we jump to our imagined solution instead of asking the question like, how do I get zero copy?
Yep. Oh my goodness. Okay, we got the
You could print the whole book. Kill all the trees.
Allow creating and writing buffers directly. Allow returning vectee.
Yeah, I mean the calling convention is kind of the thing, right? Like that's kind of what the Wasm bindgen is all about. It's all about this like marshalling process.
A Wasm boundary trait for a custom type.
It's going to be a thing where like we have to figure out like what is the word this community uses for this concept. And once you hit upon the magic word and you type it into Google, you just get like a million people all asking the same question of like, how do I move the data back and forth as quickly as possible?
Well, that's why I'm reading this issue, is because eventually one of the maintainers will come in and drop the magic word that they happen to use, that and then you can Google for that word.
Yeah, I remember when we were doing the YAPL project. We couldn't find anybody else doing something similar, and eventually we found this, whatever it was, isomorgenic or whatever the heck the crazy word was. And once you found the magic word, you type that into Google, like, oh, tons of people have projects like this where they're doing this crazy stuff. My workaround is to pass JSON. Yeah, but like if you're representing your JSON in a string, you see that. Maybe that's why that ASCII loop is so important, actually, because the ASCII loop is basically catching the JSON case, at least when your JSON is ASCII. But if you have a hugging face emoji in the middle of your JSON, you may be sad.
All right, so here they're returning just a byte stream, which you could imagine this making sense, right? This is going to be presumably an index into your memory.
Oh, you can just return pointers like a, oh.
And so then you could imagine.
I see. So maybe trying to wrap it up in a object is the wrong approach. Maybe if you really wanted zero copy, what you would just do is pass around pointers.
Well, but what's happening here though? Like, where's the unsafe, right? Like,
well, pointers in Rust are not unsafe. It's only operations that dereference pointers that are unsafe.
I see. So
well, pointers themselves, they're just numbers.
The dereferencing is happening on the JavaScript side. So like,
so YOLO,
Rust doesn't care. We're just grabbing the pointer out of this thing and returning it, and Vec is presumably gone.
No. Oh, is it dropped? I mean, you have to be careful with those things, of course.
Or maybe this is just depending on. So here, render new uint clamped array memory buffer. Yep, exactly what I thought. Texture offset. Yep, and we're depending on the idea that no one has ever deallocated this.
I see. So it's literally just taking the memory buffer and just taking the pointer and be like, "Yep, I'm going to read you."
Yep. That does not seem safe. You can use this, which should be less error prone. Okay. Show me the money. Unsafe view. Whoa.
Well, from
the
point of view of the JavaScript GC, the Wasm heap is just one giant array buffer of bytes. And so it's referenced by somewhere, so it ain't going to be garbage collected. But the question is, like, who has freed the memory inside the heap?
What do you mean it ain't going to be garbage collected? Wasm heap lives in one giant.
As always, James R is exactly correct.
Well, the Wasm heap is not going to be garbage collected, but within the Wasm heap, Rust presumably manages that.
Yeah, so like that pointer can get freed, right? And so the question is, are you reading freed memory? Like, it's not going to crash your computer because it's an array buffer and there's no, like, the pages are all there. So, but the question is it the data you wanted or is it garbage?
I like this pointer though, right? So this is linking to the actual JSSys underlying docs from FitzGen, whatever that is. And it's just generating a uint array unsafely from a U8 slice.
I see. Because the ownership is messed up here, right? It's saying we made you this uint array from this slice, but we lost the lifetime.
Oh, views in WebAssembly are only valid as long as the backing buffer isn't resized in JS.
Oh, that's another hazard. Like, how do you know when your backing buffer gets resized?
Well, presumably you hook into some by the way you're being resized, and you do a copy or something from the old to the new.
But I can see why this makes zero copy sort of hazardous, and like you have to be careful about it because you have to worry about the case where the underlying memory is being. But that's got to be like a incredibly expensive operation. Like, I resize your entire memory. Like, I'm now going to mem copy your whole address space over. That's the thing that's from a like OS implementer's point of view that makes WebAssembly kind of crazy. Is we do all this work in OSs to have complicated like sparse tree structures to represent your linear address space, and Wasm is like, nope, just here it is. It's a like a vector. The disconnection of lifetime. I think this is fascinating.
You could get around this though by returning a slightly more complicated object that did two things. One, it was basically a handle and a view, right? It both somehow held on to the Rust object.
Like a thing that like took a vec and consumed it and gave you back an array buffer, and then somehow it was JavaScript's job to make sure to free the vec or something. Instead of
I suspect there's a way to allocate one of these, right?
Anyway,
we're in the weeds here again.
We're in the weeds and we're sort of at time, and I thought this was interesting. I want to keep playing with WebAssembly. It seems like a very powerful enabling technology. I'm not entirely sure what to use it for, but it seems like it could be useful for many, many things.
My sense from our hour staring at it is there may be a lot of gotchas. it seems like a hard job to be designing the like calling semantics for every language, or something that's compatible with any language, and then also the allocation. Like the WebAssembly sort of wants to expose OS level, like kernel level primitives, and I suspect languages are going to be very confused when they don't act like an OS, like what we just saw. They're like, by the way, your physical memory is going to get resized. Move everything.
Yeah, Wasm doesn't have a string data type. That's true. It just has like bytes and pointers and stuff.
Anyways, it was fun to explore Wasm. We should think of something to do with it to press it a little further. But maybe that's for next episode.
Yeah, if you have ideas, like tweet us your favorite Wasm ideas, and we might play with them on the show.
Anyways, have a good week,
Don't forget
everyone.
to like and subscribe, all that stuff.
Good to see you, Dr. Barth.
See you next week.